Namaskaram everybody. Welcome to this new video and I have attached the link of playlist in description, so in case you haven't watched the previous video, you can check that out in description. So in the last video we set up our project and we had some basic overview of this Unreal Engine editor. I hope you played with the controls and actions that are present in the viewport, and you I hope you also checked out some basic files that were there in the content browser. Even if you haven't, it's absolutely fine. So now we are going to work on the movement system, and we are going to be taking the reference from Lyra's Locomotion system. The way they designed it, we are going to follow the same approach because I think it is much better than the traditional approach of developing the movement mechanism for our characters. So let's start. There are two requirements in front of us. First of all, to create the animations of our character, the movement animations, you are going to need the animations first. So we are not going to use the animation from third person template that we have in this. Like if you go to press control space, go in characters under mannequins. So there are some basic animations. So we are not going to use it right now. Instead, I am attaching a link of Lyra's animations in the description. It's a Google Drive link, so you can download those animations. Assuming that you have downloaded now, we are going to import them in our project. So under mannequins animations, we are going to right click in this space and create a new folder and name it Lyra animations. Okay, import those animations. So just locate wherever your animations are. You can see I have located. So just select all, press on open, and select the skeleton as SK mannequin. Okay, and import to all. Right, import all. So you'll see after a few seconds all the animations will be imported. All right, so you can see there are total 83 animations that have been uh, imported into this Lyra animations folder. All right, so now what we are going to do is we are going to duplicate this animation blueprint and we are going to name it called, let's say, uh, whatever name you would like to give to your character. For example, I will say Thunder. Okay, so we have this blueprint called ABP Thunder, and we have all the events here, just like we had in many. So we will just delete them, go in the animation graph, delete everything. Okay, once you are done, hit on this compile, right? And now if we press on play button, and if we see our character is still moving, so press escape and go to this third person, locate the blueprints pp third person character. So you can see it is using the animation class called abp quinn underscore c. So we will change it to our animation blueprint. Okay, and we will hit compile and press on. Now you can see our character is no longer performing any animations because from our animation blueprint file, we removed all the states and transitions and events. So now you can see our character is just moving. It's not performing the animations. Okay. Let's change our character's mesh to male one that we have, sk many. And if you compile, play again. Now you observe one thing, when you go W, it's going straight. Now you press A once, you see there is some rotation happening. So we also want to control our own rotation. So we will remove this. So to do that, to remove this, you go to viewport and under this you search orient rotation to movement. So whatever movement you are performing, that rotation will get disabled. Now if you try to rotate, you can see it is just moving and it's not rotating based on the movement's direction. So now we have like a very initial situation where you have nothing except the movement. Now if you want to know how this movement is coming, it's coming from this controller that we have. So you can see under mappings, there's movement action, there's a jump action, there's a look action, and it has been mapped to these keys. If you just delete or remove these, you'll not able to even move the body of the character. Now if you just close it. Okay, so now I want you to locate your blueprint that you have just created. Go into the previous scene, change this to SK many simple so that we can have exactly what we want. Apply. Okay, so our character is completely in a static pose. So the reason is that because the output pose is not receiving any poses. So to receive poses, we need an animation sequence. So to add an animation, you add a node called sequence player. So you can always right click and search and select the node that you want. So the sequence player is a node that we are going to use a lot because it plays a selected animation. Consider animation just like a video, which is a series of images or frames. Uh, animation is a series of poses. So we are going to connect this to this, and we are going to click on this sequence player, go in details, and select the sequence, which is nothing but an animation. And I'm going to say mm underscore idle. Now if you play, you can see the character is no longer in static pose, but instead it's playing the idle animation. All right. So, well, that's the first achievement. We played our first animation. You can try playing some other animations in case you just want to see if the sequence player is working or not. All right. So now it's time we set up a state machine to handle our locomotion. When I say locomotion, the movement and the different states that are involved in the locomotion system. So for that, we need to create a state machine. So just right click, search for state machine, and name it Locomotion SM. So it stays Locomotion state machine. Okay, now we are going to delete this, and instead we are going to connect this. Now double click on it, you will get inside. So the entry of this particular state machine is the what do we call as the idle state. So add a state. Okay, now name it idle. Now double click on it. Now this idle state will play an animation, will output the pose, and that pose is going to be sent to the output pose in the main anim graph. Okay, so I'm going to add the sequence player. Yeah, and connect it. Oops, and select the idle animation, underscore idle. Select both of them, press Q to make these lines straight, or press Shift W to align them like this. You can check other alignments by right clicking and trying out these alignments. I prefer top alignment. Okay, so you can choose what you like. If you like straight lines, you press Q. Okay, so now if I compile again, you see this idle sequence player is outputting the idle animation poses. Okay, and if you press back and press back again, you can see it's constantly playing, and that animation is going to our output pose. Yep. All right, so that's one. Now it keeps repeating itself. So if you just see in idle state, this sequence player node has this loop animation checked. If you are not having checked, get it checked, because if I don't check it and just hit compile, now you'll see once this animation is over, our character is no longer playing that idle animation. He's static now. He's stuck, stopped. Now, if you just select it again, now this keeps on playing again and again. Okay. So this is the loop animation. So loop animation is useful when you want to perform certain animation repeatedly, like walking, running, jogging, right? Or crouching, something like that. So that's the first objective that we wanted to achieve, is to introduce the idle animation. Okay. Now what we want next is to make our character walk. Now to make it walk, we need to make transition from idle to walk state. So we create another state and we name it add state, and we name it walk, or let's say cycle, whatever you like. And again, shift W. Now we want to transition from idle to walk when our character is receiving input. Now, to do this, I'm going to create a variable that is going to track whether the character is receiving any movement input from the user or not. And we can call this variable is accelerating. That means whether it is receiving any acceleration from the user. So this acceleration variable, if it's greater than 0, that means we are receiving some input and we need to transition from idle to walk. Okay. Okay, so before we start working on this, I really want you to understand the object hierarchy of the Unreal Engine. So Unreal Engine is built on an oops. So when I say oops, it's called object oriented programming hierarchy. Okay, so this is the hierarchy that Unreal Engine follow. Now here's a quick breakdown of this. There are four classes: U object, which is also called Unreal object. Second is actor, third is pawn, and fourth is the character. Now let's focus on the Unreal object. Everything that is placed in the viewport, okay, the base class of all these objects is Unreal object. Okay, it provides the fundamental properties and methods that you see in details and all that. Now, from Unreal object, there is a class called actor that gets inherited. Okay, the actor class inherits from Unreal object and represents any object that can exist in this game world, whatever you have placed so far, which means they have their location, they have their rotation, they have their scale, and they can be placed anywhere in the level. Okay, so if you want to access location, rotation, and scale, okay, we in short we call it lock, rod, scale. Okay, if you want to access lock, rod, scale, you always access from the actor class. Okay, so just like actor is inherited from Unreal object, there is another class called pawn which is inherited from the actor. So just like actor, there is another class called pawn which is inherited from actor, and it's a specialized actor that can be possessed. So now there is another class. The last class that I want to talk about is the character, which is our player basically that you see in the game. So this is a subclass of pawn that includes a specific component called character movement. Now this component handles the advanced movement features like walking, jumping, falling, running, etc. Let's understand this. The character movement component is a key feature of this character class because it manages the movement logic. Okay, just the name states. So when it comes to the movement logic, you can control its acceleration, you can control its velocity. They have features like gravity and physics. For example, the player, when you made the player jump on that particular uh, what is this, mesh, okay, let's just call it mesh or cube, when you made him jump and then the character falls, so that's like gravity working. When you were colliding with different stuff, the physics was working. It's a different thing, you were not able to move. So that is also part of your character movement. It provides all those kind of features or attributes that we are looking for in the game. And another thing, it allows you to do the input processing, which is what we need. Like I said before, we need to know if you are receiving an input, then only we want to make the transition from idle to the walking pose. Okay, so for all locomotion system, for now, just for this very moment, we need to know the acceleration property so that we can decide whether we should transit from idle to walk. Okay, all right. So I hope you understood what I just said. If not, just rewatch, because I think it is very important. Because now what I'm about to say is more technically complex, but I'll try to make it as simple as I can. Now, where we are going to do all these events, like I said before, there is this event graph where we place our all game logics, like I mentioned before. But for for this kind of job, we do not want to utilize the event graph. Okay, now I want you to take a deep breath and hear me out very, very carefully. So, in computer, in operating system, there is something called as thread. Thread is basically a sequence of instructions that a program runs independently. So, most of the games often use multiple threads to handle tasks simultaneously. That's why you have GPUs. Okay, that's why you have graphic card, because it allow you to perform multiple operations in parallel, not one after another. Now, this introduced the challenge. Okay, the challenge is the shared data. When two or more threads try to read or write the same variable at the same time, it can lead to inconsistent states. Okay, let's understand it from an example. Um, let's say one thread is responsible for processing the player input. Okay, so for example, you have a mouse click that allows you to perform an attack in the game. Okay, another thread is responsible for updating the animation. So I'm exactly considering an example that suits our scenario. Okay, so when you press mouse button, it will attack. Okay, it will process that input. The second thread, the another thread, is going to perform the attack animation. Okay, so from idle state it will go to attack. Just like you press W, it goes from idle to the walk state. So there are two things happening by two different threads. Now when the player press the attack button or the mouse button, the input thread sets that, let's say, is attacking to true. Just like we press W, we set the variable is accelerating to true. That means we want the character to play the walk animation, or in this case we want it to play the uh, attack animation. So we want to make that variable true. Now the animation thread, the second thread, whose job is to perform the animation work, reads the is attacking variable to determine which animation to play. Okay, so now if the animation thread tries to read this particular variable while the input thread is updating it, now this thread is updating the input actions, and at the same time this animation thread is reading that value. Now, this might lead to an inconsistency because the animation might play an idle animation instead of the attack, because the input thread was just about to update, and at that time, the value read by this particular animation thread is false. So it keeps on idle state. So when you are clicking, the click response goes to the first thread, but the second thread says, I still see attacking false. That means I have to stay in idle state. So that's how the inconsistent state has been introduced if you follow multiple thread approach. Okay, but if only one thread performs everything, for example taking input actions then performing the animation, then there is not going to be any problem. But you need to understand, if your game is big, you have a lot of stuff, then that single thread is performing a lot of work, and that puts a load on the system, and it introduced latency and other bottlenecks. So to avoid that, we want to utilize the CPU cores or graphic cards up to their max potential. We want to perform as many tasks in parallel. So to do that, we introduce multiple workers, multiple threads that does the jobs in parallel, but we need to make sure that the data that they share is accessed properly and safely. So that's why we call this function called blueprint thread safe update animation. So how does this work out is that if someone is updating any variable or any data, then the other threads are not going to read it until that operation is done. Once it is done, then only it will work. So sometimes in games, you might have observed that you are constantly pressing, but that character is not performing that animation because there is a very, very milliseconds delay. Now, this is because the CPU is working to its top performance, so it doesn't have any bandwidth, okay, or let's just say it is overburdened. So in those cases it happens, but when you buy a GPU or stuff like that, you see things are happening quite fast. You are running at 4K sometimes, so those all things are working very smoothly just because you have a very high compute power and higher number of cores or threads to work on multiple tasks in parallel. So that's the reason we are not going for event graph, because event graph uses the main game thread, and this blueprint thread safe update animation allows us to create a separate thread just for maintaining the animations. Okay, I hope this makes sense to you guys. I want to emphasize on this, but you really need to understand this. Just reverse this part if you didn't get it. Okay. All right. So we have this thread safe update animation with us. Now, what do we need to do is we need to capture whether we are receiving any input or not, right? So to do that, we are going to create a function that gets the acceleration data, or a function that updates the acceleration data in this thread. Okay, before we dive into this, I really want you to know that this acceleration term that we are referencing to right now is not the acceleration from the physics system. It's the acceleration in terms of the system. That means you are constantly sending an input. Let's say you are holding W. That means you are giving W input constantly. It's the acceleration in that sense. Okay, so I want a function that updates the acceleration data. So we take the acceleration data from the input thread and update in this thread so that other functions that we are going to have in future can access that data. Okay, so we are going to read it and we are going to store it in memory so that other functions can use it too. So create a new function that says update acceleration data. Okay, so we have this. Okay, so now right click, add a node called property access. Now this property access node allows you to access the data safely, and also there is a concept of encapsulation and abstraction in object oriented programming. You can check on web or just mention in comments, we can talk about it in another video. But the rule in development says that you should never allow access to variables directly. You should always create methods or functions that provides the value on your behalf, on the class behalf, right? So a class have methods and variables. Now we do not allow access to the variables directly, because if you can access it, that means you can update it, which we do not want. So we want methods to deal with that. So we will use this property access node, search for try get pawn owner, and inside this you can find your get movement component. Now why we are doing this is because the try get pawn owner checks whether that pawn exists in the level or not, which means a pawn, for example a coin or a treasure that you just got by killing an enemy. Now you sometime might have observed, if you leave it for too long, it just get disappeared. That means that pawn or that object, that coin, the treasure is destroyed. So this function makes sure before getting the movement component of the same object, that object exists in the world, in the level. If it gets destroyed, then you will get a null value and then your code might break. So it will return either null or the character movement component based on the presence of that object in the level. So to check that, we will use another node called cast to character movement component. Now you pass an object to this, and this is an execution pin. So what happens when you call the character movement function? This node gets executed. Now this node calls this node. Node is nothing but a set of logics that this Unreal Engine has in background, which we do not want to worry, of course, because we are using this blueprint. The reason is the same. So this, first of all, takes the value from this and it casts it and checks. Now if the cast is successful, that means that object exists and we can use its value. But if the cast fails, right, that means the object is destroyed, or maybe it just doesn't exist in the world. So getting its character movement is a bad decision. So once you have the value, you want to execute the next piece of code, that code, that is to return the value. Now to return a value, you drag a node from this, you place it here, so you can see as character movement. So this ensures that we have received something. Now let's say if this thing is destroyed, the object is destroyed, now you're not getting anything, so this cast will fail. Now to handle this scenario, we will say again return something, but that something is nothing. And okay, that is done. So if the cast is successful, we will call this piece of code. If the cast is failed, then we will call this piece of code. So since it is not returning anything, it will be null. In this, it would be the reference of the object. Now, what do we need to do next is to mark this function pure, because we want to tell Unreal that it is not modifying anything that it is accessing. So it is accessing this movement component, but it is not modifying it at all. So this function is pure. Such functions are called pure because they are not modifying any data that they are accessing inside it. Also, we want to mark it as thread safe, so it can be used by other threads safely without getting worried about the inconsistent state behavior that we talked about a lot right now. So we want to tell Unreal that it is thread safe because we are doing this cast check, so no need to worry. And to make it fully accessible in property access, we have to follow this ritual, so called, to mark the output, the return node output, as return value. It's a Pascal casing. So now you'll see, let's save it first. Now go and update acceleration data. Now we will use the property access node to find our function that we just created, that is to get character movement. Okay, you can see I have got my function. So now you will see the two rules has to be followed: the thread safe and that Pascal casing rule. Return value has to be placed to make it available in this list. So get character movement will have acceleration inside it, so let's call that um yeah, it is called get current acceleration. Okay, so now this node will give us the current acceleration from this character movement. Okay, so we will save this value in a variable. So there are two ways to do a variable. If you click on this promote to variable, it will create this variable for you and you can rename it to acceleration. Okay, it says it's already in use. Where the hell it's called exactly? Oh, okay, so just remove it and rename it again, acceleration. Okay, and another way is you press on this plus, delete it. Yes, now create a variable acceleration, change the boolean to type vector because it's a vector quantity. Now if you press and hold alt and drag it, it will bring this set for you. Now you can plug this in. Okay, so what this is doing is, first this acceleration data function is called, this is connected with this. That means after calling this piece of code will be executed. What this is doing is, to execute it, it will fetch the current acceleration from this character movement component. Then it will set that value. Then it will return that value that it received from this function. And what do we want to do next is to convert this three-dimensional acceleration into two-dimensional acceleration. Now I want you to understand is that this vector is a 3D vector, but when our character moves, it is just moving in x and y direction. So that means we only care about the x and y axis values. We do not want the z direction vector. Okay, so to um, get the 2D acceleration, we will create another variable called acceleration 2D. Okay, now this thing stores the acceleration of x and y direction only. So again, hold alt, bring it here, connect it with the execution pin. That means when the acceleration value is set, it will set this acceleration 2D variable value, and we need to give this input. So what we will do, we will get this acceleration. Now I want you to understand that this acceleration variable has been updated by this node. So now whatever happens next to this node will have the acceleration with this value that we have set here. So this is an updated value by this node. So we plug it in, but before plugging it in, we will multiply. So right click and add a node, multiply, and make this 1, this one, and z0. So that means x and y remains what they were. So the z axis value gets nullified, so it's 0. So now you make it connected with this 2D acceleration. Now have a brief look again. You got the acceleration. Now this acceleration has been set into this variable, but it's a 3D. So we need to convert it into 2D, and we need to store that as well, because both will be required in future, maybe. But we need this 2D acceleration because um, our game logic demands that, because our character is only allowed to move in x and y direction at this moment, right? Okay, so you got this acceleration 2D value, right? Now the last part, we talked about that, whether that acceleration value exists or not, whether the user is giving an input or not, right? So what we will do, we will have this acceleration 2D, hold control and bring this here. Now move it around. Now acceleration 2D will give us a value, a vector value. We need to convert it into a magnet, into a, how do I say this, scalar value, or a value, a number. So we call vector length. This gives us a magnitude. Okay, now we want to check if it is nearly equal to 0. So that means if a very slight bit of acceleration is given, we do not consider it. Sometimes you just press and release the w like this. So we do not want to consider that. So we want to consider, at least if you hold for a very decent amount of time, then only we want to consider this value. So we check whether we have got sufficient amount. So then what do we do is, okay, if it is nearly equal to 0, that means it is not accelerating. So first let's create another variable, is accelerating. Okay, so change this type to boolean, hold alt, bring this here. Now this thing will return true, because if it's 0 then it will say true, and we want to set it to false. So we apply a not node. Oops. Now where is the not? Yeah. Okay, so what this do, get the 2D acceleration, get its magnitude. If it's 0, almost 0 or 0, then we want to say it is not accelerating. Otherwise it is accelerating, because it will say no, it is not equal to 0 or almost 0. So it will, the false value will get converted by this negation to true, and it will be set to true. But now to execute this piece, we have to connect it with the previous execution pin. Okay, compile. All right, Now time to go back to our state, go into transition, bring this value. If you just bring by dragging it, it will ask what do you want, whether you want to get its value or want to set its value. That's why we use the control and alt key. So you press get, connect it with this. Now this means if it is accelerating, then you should enter into this transition, that is the walk. And vice versa, we can do that. I want to transition back to idle if the is acceleration is false. So we again return introduce a not. That means if it is true, that means it will become false. That means you no need to transition back to idle because it is accelerating, so don't. Now compile, play. Now if you see w, okay, it's not working as we expected. Let's see what's going wrong. So we will say is accelerating, then you can enter into this transition. We go and walk. Okay, we haven't attached our animation. So what was that node? Sequence player. Let's bring that guy. Connect it. Select whatever animation you want. That in our case, it's run. Yeah, run. So now if we compile again, we play. Okay, it's still not working, damn it. No, we have done everything, but we are still not calling the update acceleration data. So this blueprint thread safe update animation is run on every tick. When I say tick, that means every unit time that Unreal Engine keeps in account every frame. So it calls this function repeatedly. So what we will do is we will call our function update acceleration. Okay, it's not listed. The reason is we haven't marked it thread safe. Right, now compile it, go in the blueprint again, search for it, update acceleration data. You can see we have found it. Now if we hit compile, play our game, you can see when you press W it's running, when you hold it gets back to its idle state. Yeah. So I think that's it for this video. Remember, this function, this blueprint thread safe update animation is called on every tick. So we want it to continuously update our acceleration data, which means it is going to update all these three variables. And the animation graph is going to keep track of this variable so that it can correctly play the correct state or the animation. Okay. So yeah, thank you for watching this video. I know it's been a long video this time, but some basic fundamentals were really required. So see you in the next video, and in next video we will go real fast to set up everything that is required for the movement. All right, see ya, bye.